Okay, so here we have a look at kind of how traditional CAD packages would have worked with an assembly. Okay, so you would have kind of worked in individual part files, and these individual part files would have been somehow linked to this assembly file. You can also have had sub-assemblies, so you would break down the larger assembly into something more manageable, and that could contain part files. You can also have sub-assemblies that contain sub-assemblies and a part file, and then this sub-assembly here has part files, etc. Now this is still a valid way of working, and you kind of still work in Fusion in the same sort of way, but what you don't have in Fusion is the fact that you can somehow lose the connection between. So if you're in a company and you're sharing files, somebody might take a part file out, make a change, save it, change the name in some way, or make an alteration that causes a problem with your assembly file. And this loss of connection, or opening an assembly and it's saying it can't find the file, or the file's out of sequence or something, can be a real problem. So Fusion's got round this by having this idea that we've just discussed about this sort of root node file that's basically at the very top level, and it's the parent to everything inside, and this encompasses your whole design in here. So you've got your individual components, or as what they would know in other CAD packages is your part files, and inside these components you have things like bodies and sketches and origins and all that, and these are assembled together to create an assembly inside this Fusion file for that project. Okay, so this can contain sub-assembly, sub-assembly, etc. You also have this idea of the root node being the parent. So your root node's the parent, it's the top level of the file, and then everything else is a child from that, and that includes sub-assemblies. And the sub-assemblies, although they're a child of the root node, they can also have components that are children to them. And obviously inside every component you have bodies, sketches, origins, all these kind of things. So that's the kind of general idea of how it works. Okay, so what I want you to do is to open up this file. So it's provided on the Moodle. It's from Autodesk, and it's been deliberately designed to have a kind of fault inside it. Okay, so what I want you to do is to find this file in the Moodle, and then use the upload, and upload this to somewhere on the cloud, and then double click on it to open it up into your actual working area. Okay, so what we have here is a file called vblockclamp, and inside this we have a body, which is the vblock. So if I expand the bodies folder and click on it, and we also have what's called a component. A component or a sub-assembly which contains components called the yoke assembly, and if I pick that, you see that there's more than one part or component inside there. And if I double click that to open it, you'll see that we have a thumb screw and a clamp yoke. Now at the top level here, this is known as your root node, and it has an activate radial button beside it. If you come down to the yoke assembly, you'll see that it also has a radial button beside it, and so does the thumb screw, and so does the clamp yoke. And when you hover over it, it says activate component. Now we'll get to that in a minute, but just be aware that there's radial buttons there. The V-block, okay, this body here, does not have a radial button next to it. And the reason for that is that this is a child of the root node. Okay, and this is kind of what we've been doing up till now. So if I roll back on the tree here, right back to the second extrusion, so we had a sketch and then that's been extruded. Okay, now this is the first body that you've created in this design, and this was done in exactly the same way as we've been working up till now. So you've come in, you've picked a plane, you've drawn a sketch and you've extruded it. And in doing so, you've created a body, but you've also created a problem, and that this V-block, if I want to use it in an assembly, it cannot be a body. A body is a contiguous 3D element. Okay, it is an extrusion, for example, here, and anything else that's done to this. So for example, if I fillet the edges of this, let's just fillet these two edges and say okay, then I have added a feature to the body, but you cannot use the bodies in an assembly. Anytime you want to assemble something together, it has to be an assembly of components. So one of the the golden rules in Fusion is that, and I want you to do this from now on, is that you should always start by creating a component. So when you start a new file and you call it whatever you want, the first thing you should do is come in here, and where it says new component is click on component and create a new component. Now the component is a container, like a box that contains the body and all the rest of the information for that part. So let me drag this back out till we get back to here, and you'll see that this yoke assembly, which is a sub-assembly, contains as a component, because it's got activate component, and you can always tell a component because a component will have its own origin and joints, and if I expand out the thumb screw here, it's got its own bodies and sketches and things. So a component will contain all of the information required to make this part in 3D. A body just contains the features that are contiguous to each other. So a feature built upon another, so an extrusion, then a hole put in, then a radius, etc. That's a body, but you cannot make an assembly out of a body. Okay, the other way that you can tell the difference between these is this little symbols on the browser tree. So a body will always contain the symbol of a cylinder. Okay, an assembly, a collection of components, will contain 3 boxes, and the actual signifying emblem, let's call it, for a component is a box. So the assembly is saying is basically adding boxes together, okay, and every box is a component, and the component is a container, okay, inside here for bodies. So the body that made up this, and the body itself has all these features. So because this is blue, if I come down to here, you'll see that this screw here was made up of an extrusion and then a thread and then some chamfers, etc. And all that information, all that blue, is contained within this component container for that thumb screw part. Now, if I wanted to use this V-block inside this assembly, I can't do it at the moment because it's just a body. But a body, if you click on it, can be converted to a component. So although you've maybe started in the wrong manner, you can still save it by converting that to a component. So let's do that just now. And you see that now it's given it a different colour, and it's now a component. Okay, it's a component. If I expand it out, it's a component that contains a body, and that body is all the features that were used to create that. So the extrusion and the fillets and whatever that were used to create that. And because it's that now, it means that it becomes part of the assembly. So what I can do is I can say you're grounded, and that cannot move. I couldn't do that before. This assembly that's connected here, anytime you move an assembly, it's going to jump away, and we can go back to, we can either capture the position we've moved it to, or we can set it to there. Now that these are components, we can start to apply these things called joints that allow you to make these move in the method they would in real life. So if I use this thing here called an as-built joint, which is basically saying to the assembly, this is exactly where it should be, but I want it to move in a certain way. So what kind of movement would this have? Okay, there's loads of different kinds, but it's asking you to pick components. You notice it's not bodies, so you cannot do anything with an assembly if this V block was still a body. So the components we want are, I want this guy, this component, and it's going to pick up the entire assembly there, even though it's only highlighted that. And I want it to move along this component. And then the type of motion that we're looking for is going to be a slider, because it's going to slide up and down. And so therefore it's asking me, where do you want this to slide along? I want it to slide along that line. Okay, and if I click away, it shows you what that motion's going to be. Now it only does it for one of the components, but because this is a sub-assembly and these two parts are connected together, that's rigid inside there, that when I actually start to move that now, you'll notice that everything goes with it. Now the other thing about a component is that here we're at the very top level of the assembly. Okay, but what if I wanted to make a change to something like close that, something inside this yoke assembly? So I can come down here and I can try and find the part of the component I'm looking for or whatever. Or what I can do is I can make that active, and then if I come down into the thumb screw, I can make it active, and then on the timeline I only see the features or the bodies etc. that made up that part, that made up that component. And if I do the same with the clamp yoke, you see that I only see the features that are relevant to the creation of that part. And these are the features and bodies that are contained within the component. Okay? So, golden rule, from now on, you have to, when you start a new file, always create a new component. It's just a kind of a safe way of doing it. And the more you use this, the more you'll kind of understand this, jumping backwards and forwards between it. And I will put up a couple of links in the middle to YouTube videos of people explaining this, and explaining it probably a lot better than I have. Okay. Okay, so I'm going to do a little exercise to create a ball joint between two components, and hopefully in doing so you'll learn kind of something about bodies and components. Okay, so what we're trying to get over to you in this assembly exercises is the idea of you should always start everything with a new component. But what if you've made a mistake and you haven't started with a new component? So I'll show you how you can kind of get around that. So the first thing I want you to do is we're going to create a sketch. We're going to create it on the top plane. We're going to press S, pick the rectangle tool, and then pick center rectangle. And then let's just draw a box that's 50, tab 50, hit enter. Click finish sketch, pick that 50 by 50 square, press pull, and we'll lift it up by 10. Okay, now on the top surface here, if we select top surface, hit the right hand mouse button and do sketch, we're going to draw a centre diameter circle on there. So there's the centre, drag it out, give it a diameter of 20, click finish sketch, and then pick that closed shape, press pull, and let's drag this up by 40 mil. Okay, so what we've got is under the root node, which is unsaved at the moment, so let's save it and we'll call it test body comp. Okay, so that's our root node, this is what our file's called, and under this top level we're making at the moment a body, one body that's a combination of the cylinder and the square. Now under create you also have this sphere, so these are all what are called primitives, so you can create a box, a cylinder, a sphere, a donut, a coil and a pipe really quickly. So if we click here, instead of having to draw a half circle and revolve it or something like that, we can just say where we want to draw this. So I want to draw a sphere up on here, and then the size of it at the moment is 40 mil. I don't want it to be a cut, I want it to join onto that, and what we end up with now is our first sort of our first component that we want to use for the ball joint, but it's at the top level. Okay, it's not a component on its own, and if we want to assemble things together and assemble this to have a ball joint movement, then we need to somehow separate this collection of features into, instead of one body, we want this body to be a component. So how do we do that? Well, under the body folder you've got body 1, which represents everything that's connected here, and if I right hand mouse button on that, you'll see it has this option here, create component from body. So basically I pick that and it goes completely red, and this is because in the inspect I have this component colour cycling thing on, so if I switch that off it'll go to the default colour. But because we're working in an assembly, it's quite nice to see your different components, and it does that through the colour cycling toggle. Okay, now the thing I want you to notice is that under this component we've got this one body. Now if I want to make changes to that, you see that the colour down here on the time bar is still related to the top level. So this is why you should make your component first, because if I want to make changes to that, I'm actually having to go back up to the root node to make changes to a component that's now a kind of sub-assembly part of the root. So this can get confusing to the software down the line. So that's why I'm saying the best thing to do is to do this before you start modelling anything. But if you're halfway through modelling something, you can convert it to a component, but you just need to be aware that underneath there's no real history of how this was made. The history of this component is held under the root node, and that can cause confusion, even confusion in just explaining it to you at the moment. Okay, so let's save this here, and then we'll come back in the next video and I'll show you how we can take advantage of this now being a component to create the socket for the ball joint. Okay, so one of the advantages that using components can give us is this ability to copy this part and actually use it as a separate part to design the socket. So rather than me having to recreate this, what I'm going to do is I'm going to copy it, I'm going to paste it into the top level and make its own component, and then I'm going to make changes to that component and use this one to help design the ball, the socket for this ball joint. Okay, so it sounds complicated, but it's not really that bad. So first thing I want to do is to select the component. Okay, so this is the one we want to copy. And a right hand mouse button, and I'm going to select copy. Now I can paste this back in here and it would be a child of component 1. But if I go up to the root node and select it, I can right hand mouse button and it gives me two different options. Okay, so I can paste it, which would be just a direct copy. And if I paste it just using paste, then if I make any changes to component 1, the same changes would happen to component 2, or the new component we're going to make. So we don't want that. We want to have this as independent. We want to copy it at the moment and then make it independent, so whatever changes we make to it are not affected in component 1. So go to the top level and just do paste new, and that should give me a purple component here called component 2. And over here in the move copy, it looks exactly the same, but what I want you to do is to grab one of these handles here for the angle and drag it round to 180, minus 180, and you'll see that it's actually a separate component underneath. It's just exactly the same. So let's go to the front view now, and let's move this up roughly to where we would want it to be. Okay, so it's roughly about there, so minus 53 or whatever. Now once you have components and you start to move them, as we showed in the previous lessons, you have this thing here called capture and revert. So if I hit revert, it will go back to exactly where it was before, and it will be a mirrored copy underneath, an exact copy underneath this. But I want to capture it where it is at the moment, this 180 and moved up by 50 odd. So let's just hit capture position, and what that'll do is it will leave those two components exactly where they are. Okay, now this is the component that we want to work on, so we have to make that active. So we click activate component, and what we should get is just the history tree for this, or the time history for this part, and the original part should go grey like that. Okay, so the first thing it's seen here is this is the base feature. So I want to make this ball bigger because we want to obviously have this as the socket. So if I select the sphere, right hand mouse button, hit press pull, I can start to drag that out, and we'll drag that out by, we'll make it 5mm bigger than the ball in component number 1. Now what we could do to make it easier for you to see this is we could put a section analysis through this, and we'll pick that plane there, and then that should show you this idea of having the two components through each other. Okay, as soon as you click section analysis and pick a plane, for example, you have it added to the tree, and you can edit it. So you can drag this through forward and back you can have it set to a plane at a known distance. And if I hit cancel here, it will just remember that. I can switch it on and off by just clicking the little eyeball either there or at the top level to switch off analysis completely. So if you had multiple sections, you can switch them on and off using this tool. Okay, so let's save it there, and then we'll continue in the next lesson. Okay, so continuing on, we've got component 2. So let's rename this actually. We'll call this socket, just to make it easier to remember what's going on. And we'll call component 1 ball. Okay, so we've got the socket active, and what we want to do is we want to cut away half of it because we need it to be open underneath so that you can snap this over the top. So we're not going to do it incredibly accurately, but what we are going to do is we're going to do a sketch. It's going to be on this plane here, the front plane, so that we can see the ball. And then if you section it, if we did the section, we can kind of see where we want to cut this. So I'm going to put it just below the centre. I'm going to drag it right through. So if I switch the analysis off again, you can see what we've got here. Right, so I'm going to click finish sketch. So you have to make sure that the cutting tool is beyond the dimensions of what it is you're cutting. Okay, so it's beyond this shape. So if I pick that and I say press pull, then we can come up here, we can say symmetric. As soon as I start to drag it, it's going to cut through both, and you can see that it's cutting through both objects there. So down here at the bottom I've got objects to cut. So I don't want to cut body 1, which is the ball, I only want to cut the socket. So if I switch that off, that will appear, and click OK, and it should only cut through the socket. Okay, so we can see the shape starting to come together. So now what I want to do is I want to remove this sphere from the socket part to leave the cavity that would snap into. So how do I do that? Well, we can use this combine tool and do a boolean operation. Okay, so select the modify, combine. Target body is going to be the socket, the tool body is going to be the ball, and we want to keep the tool, we want to keep the ball, we don't want to lose that. So I say OK. And what we should have now is, if I hide the ball away, there we have the cavity created. It's exactly the same size as the ball that's going in there. Okay, so if we have a wee look at the analysis, you can see that it's cut the socket out of there, and that's kind of what we want. Okay, so at this moment I'm going to come back up to the top level and make that active. Okay, so we should have our two components, the ball and the socket, and we want to use this again to use the volume of this to cut out the little kind of C shape that you have around these sockets, so that it can easily snap over there. And we're going to use the geometry of the ball to do that. Okay, so the first thing I want to do is, with the ball, I want to ground it. Okay, so because we've got components now, we have to make sure that one of our components cannot move, so this guy can't move anymore. I'm then going to pick the socket, and I'm going to press M on the keyboard, and that gives me the move. Okay, but I want to rotate this, but I don't want to rotate it around the axis that it has given me at the moment, okay, this point here. I want it to be around this object. So again, I have to come over here and I pick this set pivot. So that now says to me, where do you want to put this pivot? You see as I move, it gives me all these options. So I want it to be at the centre of this ball. So I bring it, I click on there, and that's it. Put that pivot right in the centre of this ball unit here. And if I come over here, I have to make sure I click done, so that it knows that that's where that stays. That then allows me to rotate this part around that pivot point. And if I rotate it around by 90, and then put capture position on there, and say OK, then it gives me these two components clashing. And now what I have to do is to remove this volume from this, and that will give us the shape for the little cutout that's going to be on the face of this socket component. So again, we use combine. Target body is this one. Tool body is this. We're going to do a cut. We're going to keep the tool. Click OK. And if I hide the ball away, you'll see what I mean about that cut. So this cut now, we need that 4 times round the face of this object. So we can do a circular pattern. It's going to be a face, so it's this face here, and the axis is going to be around this circular edge, or this circular edge. So around this circular edge, you see there that it's given us 3, we want 4. So we click OK, that will give us the 4. Bring back the ball. Again, you can see it's cut that volume out of there. And now because we have a component and we've got it in place exactly where we want, we can create an as-built joint, like in the first exercise. So we're doing an as-built joint of a ball between this component and this component. And the position, where do we want to rotate it around? We want the same axis as we had before around the ball, so we pick the sphere. And because that was the one we picked first, so let's do that the other way around, sorry. So we want this guy to move round this one. And the position should still be the same, and there we start to get the ball joint. And if you click preview, you can see it moving round. Okay, so basic premise: if you make a mistake and you start modelling, you can turn it into a component later on, but it's not advised. And then once you've got components, there's a lot more sort of things that you can do with them, using this combine and cut and whatever. And the other thing you have to be aware of is this idea of activating the component that you're working on. Okay.